let's have a conversation then. Allison, you were in group A, right? And you did f of g of x. What'd you get for f of g of x? You got x. And Abby, did you do g of f of x? What'd you get? You also got x. Eden, what about you? Did you get x's? You got x's. Reese got x's. What about group C? You also got x's. And group B, which had the more challenging algebraic fun of plugging one cubic into a cube root or a cube root into a cubic and then simplifying, you also should have gotten x for each of them as well. And if you didn't, it suggests that there's a little algebra thing happening there. And what I noticed was in this one, a number of people threw this +1 away. When they took this and plugged it in here, they inadvertently dropped that. Remember, you're only replacing x with this stuff. So this -1 and that +1 would cancel, allowing you to take the cube root of the cube. So I'm a little confused and concerned about this because yesterday when we were doing some composition problems, we didn't get x. Like it never came up. Like we did a bunch of composition, F8G, G8F. Was this the class where we even did F eating itself? Yeah, and no, never came up with x. So what's the deal that you guys got x, and you got x, and you got x, no matter which composition we did? I mean, it's just like completely bizarro to me that this could happen when yesterday it didn't happen at all. Yes. Flippables. That's a great word. Would anyone like to use another word that maybe they've heard before? Yes? Can someone read the daily objective? Inverses. Flippables is nice. Flippables is nice, but these are inverses. This is, in fact, we know these functions are inverses because f of g of x equals g of f of x equals f of x. Okay, so let's get that on the board as the beginning of our review for inverses. We know no, don't minimize the other option. Tough crowd. Okay, about a second to go. Oh, I'm about to use some notation where if you forgot the word inverse or maybe didn't really know it, you may want to pay really close attention to what I'm about to write. F of f inverse of x equals f inverse of f of x equals x. See this notation here? This isn't raised to the -1 power like you might be inclined to think. But Mr. Kukla, it looks like it's raised to the -1 power. Yes, I know. And the word there is spelled T-H-E-I-R, except when it's spelled T-H-E-R-E. I only know by context which there we're talking about. I only know because tonight's homework is all about inverses that whenever I see this symbol means the inverse of function f of x. It does not mean in tonight's homework this. Does not mean that. That is not f to the -1 tonight. Sometimes f to the -1 means that, but not tonight it doesn't. And how are you supposed to know when you inadvertently are walking through the woods one day and you come across an f to the -1, which of those two options it is? Only by context. You'll have to have a conversation with that function and figure out, are you an inverse or are you a reciprocal? I don't know unless we talk. Okay, So, but on tonight's homework, and generally speaking, when you see this notation, we're talking about an inverse. And the first thing we've said today about inverses is that when you compose inverses, either f of g or g of f, you end up with x. In fact, in your homework tonight, you're going to see the word verify the two functions are inverses. And when they use that word verify, they're very explicitly telling you, you need to do this, and you need to do this, and each time you do those, you should get this. If you see the word verify, that's what you're going to be doing. Yes, ma'am. Well, the cool thing about the word verify is it implies that they are, and we just want you to show that you know that too. Now, the people in group B will feel a little bit like, well, but the first time I did the problem, I didn't get X. And so I kind of find it reassuring when I do these verify problems that if I don't get X, I made a little mistake someplace. Maybe it was a distributing mistake, maybe it was an adding mistake, maybe I dropped some part of the function out when I plugged something in. A little mistake has been made because you really should get X each time. Now, there are going to be some other questions that say, hey, here's a function, find the inverse of this function, and then show that they're inverses by doing this. So let's imagine that you made a mistake making the inverse of the given function. And so when you do the composition, you don't get X. Well, that's not because you made a little mistake along the way, except that your inverse was wrong. Because you know that a function composed with its inverse should always equal X. So the two places for mistakes are, you do this composition, but you had a little error in the simplifying part, or you created the inverse, but you created the inverse wrong. When they give us the two functions, when they ask us to verify, always equal to X. Okay? Any other questions so far? I want to talk about inverses three acts today, 3 ways, 3 topics today. The first topic is, how do I know if a function has an inverse? I think this is actually going to be the toughest part of our conversation. So it may require a little persistence on your part. The second part of the conversation will probably be the easiest part. How do I make the inverse of a function? And the third part of our conversation today, we actually just started. How do I know if 2 functions are inverses? And one way I know, Riley, is to verify with composition. Okay? All right, so this is what I want to talk about. Let's start first with, how do I know if a function has an inverse? So, what can we say about that? Well, we know that these functions all had inverses. Lots of functions have inverses, but not all functions have inverses. Let's take a look. Actually, if a function has an inverse, that function is, and I'm going to change colors here because I think it's kind of important, 1, 2, 1. I think it's kind of important because these 3 words, one-to-one, and their meaning, people generally know by the end of class today and completely forget they ever saw them by the time we get to next Friday's test. So this would be something to put a star next to so you don't forget this vocabulary. Okay. All right, what does that mean, one-to-one? Does anyone have a sense of it? Kate? No. Wyatt? Well, look at A, B, and C. Those are functions that are inverses of each other. Are they the same? Only when I compose them. Yeah, that's not quite one-to-one. Mariah, one-to-one? Okay. Yeah. That's really good. And that's kind of what Wyatt was getting at too. I really like that, digging into the meaning of that whatever is going to happen with these inverses, we're going to notice that they have to have some sort of relationship which allows us, when we plug one into the other, things cancel, things cancel, things cancel, so that you're just left with X. It's sort of like if we extend yesterday's metaphor of horrible way of making babies, F eats G of X, that what we end up with in this situation is the digestive acid inside F of X's belly leaves us with only the bones. No extra bits for little baby H of X. That's all we get. It's kind of grim. I don't really like thinking about it that way. All right, I said this was the hardest part of the conversation, but I think it's worth digging in just a little more. Let's try this. Let's remind ourselves about a function. How do I know if I'm looking at a function on a graph? How do I know graphically? Yes. Passes the vertical line test. How do I know if I'm looking at a table if I'm looking at a function? No repeating X values. No repeats in the domain. Okay. So let me say this. I'm going to put up 3 T-charts here. X, Y, X, Y, X, Y. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 5, 5, 5. 5, 5, 5, 5. 1, 2, 3, 4. Is this a function? Is this a function? Is this a function? Okay. Because I'm not a function, I don't have an inverse. Anything that's not a function doesn't have an inverse. Don't worry about it. So now we've got these two. One of these two is one-to-one and therefore has an inverse. One of these two is not one-to-one. And I'm wondering if someone can tell me what one-to-one means. It has something to do with our conversation about functionness, Brad. And that's what functionness meant, right? We would say for a function, each input goes to one output. But this is one-to-one, so we want to add a little something to that. No, but that's nice, but no. Yes. Say it again. So Brad said, no. Let me build it. Brad said each input goes to one output. And I think Brian is saying this y value goes to only 1x. Each input goes to only one output is a function. Each output only goes to one input is the inverse is a function. Each input goes to one output. That was our definition of function. But now we add and each output goes to only one input. And this tells me the inverse is also a function. Woof. And that's what one-to-one means. One-to-one means one input for each output and one output for each input. It means both the original is a function and the inverse would be a function. When I'm told that a function is one-to-one, what I'm told when I know a function is one-to-one is that that function has an inverse. If I see on next week's test the directions, is this function one-to-one, you should know I'm saying, does this function have an inverse? Okay? That's what I really need you to walk away with from one-to-one. Does this have an inverse? So let's go back to our table. This one wasn't a function, so we threw it away. Is this one-to-one? Because each of these inputs goes to a different output, and each of these outputs goes to a different input. What about this function? This is a function, everyone said, but does each output go to only one input? So this is not one-to-one. It is a function, but it does not have an inverse. No inverse. And we might hear Riley saying, just like repeated domain wasn't okay for function, repeated range isn't okay for inverse. And if I have either repeated range or repeated domain, we're not going to be talking about the inverse of that thing. Okay? So now I know how to determine if a function has an inverse by looking at a table. If I see any repetition in the domain or in the range, then I say this thing doesn't have an inverse. But what if I'm looking at a graph? How can I tell graphically if I have a situation like this or a situation like this? Yeah. And it can't, say it again. This has to pass the vertical line test. This has to pass the horizontal line test. Has to pass both. In order to have an inverse, f of x must pass both the vertical and the horizontal line tests. Or, as Riley told us, in order for a function to have an inverse, there can be no repetition in inputs or in outputs, comma, the function must be 1, 2, 1. Okay, so we have two ways of knowing whether or not some function has an inverse. One way is Brian's visual way. This thing has to pass both horizontal and vertical line tests. The other is Riley's way of saying, well, I'm not allowed to have repetition in inputs, or that wouldn't be a function. And now, because I'm talking about the inverse, I can't have repetition in outputs either. Okay? Any questions about this? So that's the tough topic for the day. How do I know if a function has an inverse? Second topic. How do I make an inverse? Anyone remember at this point? We've sort of warmed up to talking about inverses a little bit. I will tell you that this gesture is often the gesture that teachers use in the United States when talking about inverses. Anyone recall? Hey? No? No. You never heard about inverses before? But gone. Okay. Yeah? This was verifying, yeah. I taught you the last stuff first. Okay. How do I make an inverse? This is what students usually tell me. Well, you know me. I like to be a little more specific. I like to say switch inputs and outputs because they aren't always x's and y's, and solve for output. But I'll tell you, Riley, in 26 years of teaching, I haven't been able to get any kid to switch to this. Everyone always tells me this. So, but that's okay. I mean, just, you know, switch inputs and outputs, switch x's and y's, and solve for y. And so, you know, algebraically, if we look at something like, yes, y equals 3x plus 6, and I'm asked, hey, what's the inverse of this? Then I'm supposed to do what, Audrey? See, I saw your fingers do that as though you had done that before. Switch the inputs and outputs, so we're going to have x equals 3y plus 6. Am I done at this point, Edra? No, what do I still need to do? 4. Yes. Great, solve for y. So I'm going to have x minus 6 equals 3y, and then I'm going to divide everything by 3. And so I'm going to get 1/3 x minus 2 equals y, or as we can now call it, f inverse of x. This is the inverse function. Some people get upset at me at this point, and they want to do this. X minus 6 equals 3y. Mr. Gukla, why can't I just divide all of it by 3? Why do I have to divide each thing by 3? Wouldn't x minus 6 all over 3 also be the inverse function? Sure, it also is the inverse function. You should be comfortable with both of those approaches. Any questions? So that's algebraically. What about from a table? Numerically, how do I make the inverse? increase. Switch the inputs and outputs. 5, 6, 7, 8, 1, 2, 3, 4. All I have to do is switch the inputs and outputs. I said the second part would be the easy part of class, because all I'm doing is switching, switching, switching. So if, for example, I have a graph, with some points on it, like -1, 4, 0, 1, and 1, -3, and this is a graph of f of x, then what can I say about points that must live on f inverse of x, Ryan? No. 4, -1. So I'm going to go over to 4 and I'm going to go to -1. 4, -1 will be a point. Good. What's another point? 1, 0 is going to be a point. 1, 0. And the third point? -3, 1 will be a point. -3, 1. Now, what I can say about this inverse thing is inverses always reflect across the line y = x. When I look at their graphs. Okay? Okay. Whew. How do we make an inverse? Eden, how do you make an inverse algebraically? Good. Sean, how will I make an inverse from a table? Fabulous. Rayleigh, how will I do this from a graph? How will I make an inverse from a graph? Am I switching the signs on those points, Ryan? Just switching the input and output, switching the x's and y's. Great. So that's Act 2. How do I make an inverse? Oh. There's a little cautionary footnote here that we should look at. Does this pass the horizontal line test? Does this have an inverse? No. This does not have an inverse. But look. Hey, Eden, what was I supposed to do algebraically to make an inverse? And then don't forget the plus or minus. Was I able to follow our process for making an inverse? Yes, but guess what? This doesn't exist. But I'm looking at it, Mr. Kukla. Yeah, I know, we're all looking at it. But this is not the inverse. Because check it out, let's graph it. It comes in two pieces. One of those pieces is positive square root of x. The other piece is negative square root of x. Does this pass the vertical line test? And therefore, this isn't a function, and I don't say it's an inverse unless that inverse is a function. So I've really got to be on my game here. This, even though I go through the process, this has no inverse. I know right from the start that this does not, as Brian said, pass the horizontal line test. And because it doesn't pass the horizontal line test, all I say is this has no inverse. I don't do this extra work. I stop. But it's really hard. Sometimes we just get into that, just get the problem done, get the problem done, get the problem done. And I see so many students starting with step 3. Like they're just on autopilot, cranking through this stuff. Instead of starting over here, can I even take the inverse of this? No. Oh, then I'm done. Just be done. Move on. Okay. Any questions about that, Audrey? Sorry, it's a very big stick. I know it's a big stick because we're on the second floor. It's a big stick. It's coming up to the window height, so it must be a big stick. Okay. Raise your hand if you are sad at the implication then that we have to throw away all parabolas because they'll not pass the horizontal line test and we can't use them for inverses. I'm sad. I spent a lot of time with parabolas. No absolute value of x, no parabolas, none of these cool, funky fourth degree shapes, not even this third degree polynomial, because all of them fail the horizontal line test. And that's a little sad. I can see Araya right now is just clutching her head saying, no. And don't worry, Araya, you're not the only one who feels this way. There are other sad mathematicians too like you, and here's what they came up with. If I restrict the domain of this parabola, I could restrict the domain in such a way. Do I pass the horizontal line test? It's all good now. Now I bring this up not because you're going to be asked to restrict the domain, but you may see this showing up in some of the problems. And the reason that's there is to allow something that otherwise would fail the horizontal line test and not have an inverse to now be able to have an inverse. The inverse of this function, f inverse of x, is our positive square root of x. This passes the vertical line test. If I only look at half of this parabola, I only get half of this parabola, and therefore this passes the vertical line test. So these can be inverses, and I would like to see them reflecting across y equals x as well. Any questions about that? Okay, last thing then. How do I know if two functions are inverses? And I would like to be able to answer this question algebraically. I'd like to be able to answer it numerically. I'd like to be able to answer this question graphically. What can we say? How do we know if two functions are inverses algebraically, graphically, numerically? Madison, I don't think I've heard from you recently. Maybe if I stand in a different position in the classroom. How will I know if two functions are inverses? Was it opposites? There was some relationship that Mikkel was talking about where they had to be able to undo each other. Under what circumstances? When I added the functions together? Under what circumstances? Caden? When I compose them. Madison, under what circumstances? Yeah, when we do f of g of x or g of f of x. So one way for me to know that two functions are inverses is if f of g of x equals g of f of x equals what, Madison? When I do that composition, what am I supposed to get? An x. And Riley says if I don't get an x, I probably made a mistake. Okay. 2. What if someone gives me some tables? Are these inverses of each other? Mikkel, how do you know? Yeah. We know that these inputs should be these outputs. No, not the same. We know that these outputs should be these inputs. Close, but no, not the same. So the inputs here have to be the outputs here. The outputs here have to be the inputs here. If they're not, numerically, sorry, these aren't inverses of each other. Any questions? Okay. And then graphically, Rayleigh, how will I know graphically if the functions are inverses of each other? If they reflect across y equals x is one thing I'll know. Good. Two. If their coordinates are switched. Very good. So let's say I have these and these. 1, 0, 2, 1, 1/2, -1. Here's f of x, here's g of x, and I ask you the question, are f of x and g of x inverses of each other, Parker? Couldn't hear you. Yes, how come? Opposite kind of? Do you mean we switch the inputs and outputs on each point? Good. And what was the other thing that we wanted to see graphically? Eden? They reflect across y equals x. Right. Okay. So how do I know if a function has an inverse? How do I know if a function is 1 to 1? Will you answer that question on your whiteboard? There's two different functions there. Each of them passes both. The question again was, and try not to look in your notes if you can, the question is, how do I know if a function is 1 to 1, or how do I know if a function has an inverse? Either one of those. If you need to look at your notes, look at your notes, but if you can do it without looking at your notes, that's even better. How do you know if a function is 1 to 1? How do you know if a function has an inverse? There's a lab coat over there. Okay. Magical cape. Sure do. Can't say math magician here without having a magical cape over there. What did you say? Cape? Cape. Because I'm a math magician. It says so on my name tag. 5, 4, 3. Actually, I think the real answer is because students have given me capes. 1. Okay, we all have a lot of writing on our boards. Marielle, what do you have on yours? Tell me one of the things you wrote. Had to pass the horizontal and vertical line test. Elizabeth, do you have that? No? You might want to add that. Kendall, what's another thing you have on yours? No repetition in domain or range. Each input has one output. Each output has one input. Any questions about this? Okay, next question for your whiteboard. Please answer this question on your whiteboard. How do I make the inverse of a function? How do I make the inverse of a function? 5, 4, 3, I do get the point. I've never seen it written like that, which is why I kept having to look at it some more. 2, 1. Switch the inputs and outputs, switch the x's and y's, solve for y if we're doing it algebraically. Does this ring a bell now? Like, do you kind of remember you might have done inverses before? Because when we started, you guys didn't remember that. Okay, well, maybe it's new for you, and you've got inverses. Have a great weekend. Hey, if you've been getting partial or no credit on homework assignments, you might want to go to your portfolio, pick up those assignments, and fix them over the weekend. Weekends are good for catching up on things like that. Thank you. Have fun tonight, gentlemen. Yeah. Take care, Fiorella. Bye, Paris. Yes. Yes. I just have to... No. Oh. Do I put... Yes, you can put absent work in there as well. I just need...